I'm assuming you can see my screen. Missy, can you confirm?
Absolutely, you're good to go.
Thank you. Great. Excellent. Thank you so much for joining us today for this webinar. This will be the last webinar in our 8th season of the NGSS ESS Working Group. So we're happy to have you joining us today for this webinar. The webinar is being recorded, and today's webinar is called Teaching Earth and Space Science with PhET Interactive Simulations. And this is one that we have been very anxious to have for quite some time. So thank you to our presenter, Rebecca Vieira, for joining us and giving us all of this great information about PhET and the simulations that really will help to support investigations in your classroom. During the course of the webinar, we would love to have you use that chat box as a discussion box. So really, it's not just a place to drop your questions, it's really a place to share ideas and thoughts as the presentation is ongoing. So feel free to put questions there, but if things come to mind, let me say it differently, when things come to mind, please go ahead and drop them into the chat box. We love to have that conversation going kind of as a back channel there. At the end of the webinar, we'll give you the post-webinar survey information again. So you do want to hang out for that. And as I said, this is the last webinar of our 8th season of webinars. Please watch your inbox for information about season 9, which will begin in September. And as always, our entire archive of webinars is available on the American Geosciences Institute YouTube channel. So please check it out there. And I am going to go ahead and turn things over to Rebecca here at this point. So let me stop sharing. And Rebecca, the screen and the audience is yours. Look forward to seeing the discussion in the chat box. Take it away, Rebecca.
All right. Thank you so much. And welcome to everyone. So just to give you a small bit of context and background on who I am the Associate Director of PhET Interactive Simulations, like I know was already said. I taught public high school for 7 years in the great state of Illinois. And my background is very much as a physics person, but I love physics in context, which means I love geosciences, I love heliophysics, I love all that astronomy, you know, great stuff like that, all the Earth and space systems kind of stuff. So I'm excited to be here. And I am hoping that I'll share something that's for everybody. I'm actually curious before we start, maybe if you want to just drop in the chat, how much do you know about PhET from 1 to 5? A 1 means, you know, I really don't know anything. Maybe I've heard of it, but I've never used it. A 5 would be, I use it on a regular basis, and it's kind of a, you know, it's a major part of my teaching. I look for it and I use it whenever I can. So let's see where you all are. So a lot of 4s. We do have a few 1s, which is also great. Some people right in the middle. Okay, we have a variety of people, just like I expected, which again is great, and I hope that I'll be able to cater to everybody. I used PhET simulations starting in 2005, before I was even certified as a teacher, and so I've seen things change dramatically. And I can tell you, having been familiar with PhET already for like 15 years, more than 15 years, there are still things that I am still learning, and you will probably see that today because I'm not as familiar with all the Earth and space science stuff. So I'm going to share my screen and get us started here. I've got a few slides, but then I am going to ask you to engage and to look at some things on the PhET website. And then also, I think we will go ahead and do some breakout groups so that you can talk to each other and I'm not just talking at you. So the goals I've kind of set for us are fairly simple. Hopefully within the next 45 minutes or so, you'll learn how to find simulations that are useful and relevant to you. And also, hopefully, you'll know where to find support for using PhET simulations, because it's one thing to have resources, it's another thing to know exactly what to do with them. So you may or may not know, PhET actually began as physics education technology because our founder, Dr. Carl Wyman, won the Nobel Prize in Physics in 2001. And at the very peak of his research career in physics, he said, number one, people aren't understanding what I'm talking about, so we need to support people in math and science education. And number 2, we need tools to help like illustrate these sometimes very abstract concepts and principles. And so he really did kind of a career shift, invested his winnings from the award into what is now PhET interactive simulations. And PhET simulations are not videos. They're not really games. I think about them kind of like virtual laboratories. So I'll show you some in just a moment. But the idea here is that we basically want to make learning STEM more like doing STEM, which means student-centered learning, active learning, inquiry, and all those buzzwords, right? But really it's to place that sense of agency with the student, because one thing we've realized is when you are in a very, let's say, a traditional classroom where maybe students are expecting to be passive listeners and the teachers are just presenting information, the moment you give the students a simulation, something they can engage with, they start to ask a lot of questions, sometimes even more questions than if they were in an actual physical lab. I believe we need to merge all those things, right? Good teachers do a lot of everything. But simulations are really powerful because you can't break stuff. And they know that students know they can experiment a little bit. So we have over 160 simulations. All of them are free from the website. They can be downloaded, used offline, that you can even send them to people via like Messenger and WhatsApp and stuff. They're just HTML files for the most part. And teachers can use them in lots of different ways. They can be homework, small group activities. It can be, you can use them as demonstrations, all different kinds of things. So let me briefly take you to the PhET website, because I want us to find a simulation on that website and I would like us to engage with it. So I'm going to stop my screen here and I'm going to pop this link into the chat and you can follow along with me. I'll also give you the direct link to get to the simulation. But I know most people probably just like type in PhET and then whatever it is you want to study. So PhET energy or whatever, and you let Google do that work for you. That's great. But if you go to the PhET website, there's so many more resources that a lot of people, including myself, overlook. So we're going to go to simulations. I'm just doing it from the top here. You can also select from down below, but I'm going to just look at all sims. And then we have a filter on the side. The simulation I would like us all to go to is my solar system. And I'm going to click on the actual simulation, and then this link right here, I'm going to pop it in the chat so that you can also go to it. And I'm going to take a little bit of a risk here because simulations are meant to be not entirely self-explanatory, but they are meant to help students inquire. And the first thing we recommend is not to give instructions. The first thing we recommend is to ask students, what do you notice? What do you wonder? What can you build? What can you break? And so I have just placed that link in the chat, and I would like to have us go into breakout groups. We'll put you in groups of somewhere between 5 and 8. And I'm going to give you 5 minutes to play with that simulation. Think about what's interesting. I don't have any specific learning objective for you. I just want you to get familiar with the controls and figure out what it's all about. So could I get support from, I think it was Ashley? Can you go ahead and, okay, looks like the breakout rooms are assigned. I'll give you 5 minutes. We'll go until 15 after the hour. I'll send a quick message through the broadcast system to give people the prompt again.
This meeting is being recorded.
All right, welcome back, everyone. Good. Well, so I'm curious to know, maybe if we could do by raise of hand, for how many of you was this the first time that you used this particular simulation or any PhET simulation? See, Greg, Tish, Hillary, Ed. Okay, so quite a few of you. I know some of you said you were familiar already with the gravity and orbits PhET simulation. It looks similar on the outset, but it does some different things. How many of you had used it before? Anyone? Oh, okay, one person. Helene, great. And Raul, I'm guessing. And Ed still has his hand up, but I think he was the first one, not the second. Anyway, great, thank you. Good. So I would like to hear from a volunteer, ideally somebody who would be willing to share their screen. What did you notice? What did you wonder? Who would like to do that? There's no wrong answers when we're asking for what did you notice, what did you wonder? Can't do poorly at this. Would anybody care to share their screen?
Okay, the first time I used it, which was earlier in the week, because I was looking for something else and this one looked more interesting, was I wanted to be able to create something that looked like our solar system, and I wanted to see what would cause an elliptical orbit if we put in more than one planet. I saw the gravity vectors, and I wanted to see what it took for something to get sucked into the sun, which
Nice.
is a kind of experiments you can't do in real life.
Right, absolutely. Yes, yeah. So what would it take to get sucked into that central object or the sun? That's a wonderful question.
Okay.
Thank you for sharing. Would somebody else like to share? And feel free to share your screen too. You can show us what you did too. Lindsay, sorry, go ahead.
I can share very basic things. I have some familiarity with another similar simulation.
Please do.
I'll share my screen. It's not much to look at, but
That's okay.
So I just noticed some of the other things you can turn on and off that might make it easier in a simulation to see what's going on. So I turned on the grid lines, I turned on the path, and I like how it shows the path. I did notice that this one's been running for 54 years now, and since it's trailing the same path, the original path goes away. If I play with the masses, for example, and it makes other crazy paths, they stick around. It's only, I think, because it's doing the same path that the path kind of disappears. And then I was at the end of the breakout group, we were talking a little bit about like the units are just mass. So it's more of like a relationship between the masses as opposed to like the actual amount of stuff that we're working with.
Looking at those proportionalities and underlying principles, would you mind clicking on where it says lab down below? You might have noticed there's a grayed out icon there. Suddenly we have units.
Yeah.
So one thing that I know I think I overlooked a few times was that the fact that there is like varying levels of complexity. So depending upon where you're teaching this, you might come back to the same simulation again and again. Excellent, thank you. I'm seeing that there's some other questions about if the planets go off the screen, can I get them back? So I'm hearing a few different things, right? I'm hearing some things about like, what do things represent? What can I visualize? What can I not visualize? I'm hearing some really interesting questions, right? Like these hypothetical kinds of questions. I'm also hearing logistical questions, like what happens if I push this button? And so I know the natural tendency for me as a teacher was to set students down in front of the computer and then give them an assignment to work on. And that really, really discourages people from like launching straight into teacher presented questions, because during those first 5 to 10 minutes, students will explore probably more than anybody would have expected them to do, more than most teachers would expect them to do. And on top of it, it's so critical to have students become familiar with the scenario, become familiar with what the buttons do, and start to make sense of representations. So if there's anything that I hope that you can get out of this, that first thing is give students that liberty for 5 to 10 minutes to just truly explore, because PhET simulations are designed to be engaging enough that should happen without you needing to prompt it. I'm going to go back to a few slides here, and then we will definitely be looking at some more simulations, but thank you to everybody who contributed. I was super glad to hear, and you can share anything else you wanted to share in the chat. I don't think we're going to go through this right now because I want to get to some other variety of things, but like, was mentioned, like, Julie was mentioning, you can look at things like relationships between mass, velocity, and distance without even like having units, right? That's a place to start. I heard, I think it was Helene who mentioned the, making the circular elliptical orbits. And I saw some really cool stuff, like some loopy things that people were doing when I popped into the room. So there's a lot to explore there. The other thing that I wanted to kind of emphasize today is, development of concepts. A lot of people, I think, including myself, looked at PhET simulations kind of as these insular, modular kinds of things. But there's so much that can be done to like really build on these learning trajectories or storylines. So atmospheric interactions with light is just one example. You may not have linked these things before, but in the simulations, but gases intro to gas properties, to thinking about greenhouse effect and atmospheric gases, and moving into things like understanding the relationship between molecules and particular forms of light. I'm just going to show a couple of these things real quick. Because again, I started developing favorites when I was a teacher, and then I would go back to those sims again and again and forget the fact that there was new stuff that was being developed. So this is a fairly, simple gas kind of a scenario where you can add heat to, of course, change the pressure. I can also do things like I can open the box if I wanted to. And I should be able to change the volume as well. There's a lot more ways that I can quantify this. And then I could specifically take a look at the gas laws. So that's just one example. And then I can build those concepts through more complex gas properties. I could take a look at energy. I could take a look at diffusion. And then I can move into things like, sorry, I've got too many things on my screen here. The greenhouse effect. This one just got republished, and you can change greenhouse gas concentration. We can add some sunlight. And I remember this concept being so difficult as a student, understanding that first we had visible, sunlight that's coming in, and then it's the infrared that's being produced on the surface of the earth. And I think this is such an awesome visualization for that. Recognizing that some of it does escape back, but a lot of it gets trapped. We can add in, take away clouds, and we can also take a look at it using a photon model. And also, I actually don't know what this one does because I haven't used it before. So, but it looks like I can change the amount of infrared absorbance. I can change albedo. I can also change solar intensity, which I think is really exciting if we're starting to look about long periods of time. So, has anybody used this one yet? I'm curious. No? PhET is always coming out with new things. So I hope that those are helpful. And then here's one final one, which takes a look at various types of molecules, including, well, these are all atmospheric kinds of stuff. And we can take a look at how does, infrared light interact with various types of molecules or versus visible light and also ultraviolet light. This kind of stuff would have been super helpful to me when I was a student, and certainly would take me beyond what I'd call a simple model of climate change. So that's just one example of a trajectory. Another trajectory here, I won't go into these simulations because I want to give you all time to explore the PhET simulations yourself, but Earth's place in the universe, there's a few things that I think could be connected. Understanding the fundamentals of waves, electromagnetic spectrum can start with looking at waves on a string or waves on a slinky. Getting even more complex, starting to look at things like interference and diffraction. And once students have that really deep understanding of light as an electromagnetic wave, looking at things like black body spectrum. You can get Wien's law from this, taking a look at, frequency of light and intensity, colors of stars. And then that leads to those wonderful questions about why don't any stars look green to us? Our Earth star is green, but it does not appear green. Why is that? And so we have another simulation, which I think is classified under biology, which takes a look at how the human eye perceives different colors of light and their combinations. So I hope that you can take a look at things like that. The thing that I would like to do actually right now, I'm going to just skip ahead a tiny bit. I would like to put us back into groups. I'm going to give people 10 minutes this time. And what I would like you to do is to think about the simulation you all engaged with. And I would like you to find a few other simulations that you could see like linking into a learning progression. So think about what might be your learning objectives. There's lots of different things here. And what other simulations could be related to that? And when would you integrate them? Before, after this particular simulation, etc. Let me stop my sharing and get a thumbs up from people. Do you understand kind of what I'm asking you to do? A 1 is well, okay. I see people give me thumbs up. That's great. I would normally do the fist to 5, but a thumb is a 1. That's not
A login and a password? Are there some that you need a login? Are they all open access?
They're all open access. There's a teacher, the teacher resources are behind a teacher account, which is free. I'll gladly explain how to get access to all that kind of stuff, but there's no paywalls from the website. The only thing
That's what I was trying to tell you.
yeah,
Use the teacher account to get all of the worksheets. And somebody will tell you how to use every simulation. If you go on it and you're absolutely floored, somebody's worked through all those problems and will tell you what to say to the kids.
Perfect.
great. Thank you, sir. I think I just cut out for a moment, so I may have missed part of that. Are you hearing me clearly?
We can hear you, Rebecca.
You can hear me now? Okay, all right. I think we
Yes.
just had a momentary thing. Yeah, thank you for sharing that. Okay, it looks like there might still be a little bouncing in and out. Hopefully it'll be okay in a second. Could I get a volunteer who might share with us some other additional linkages that they saw with my solar system?
I'd be happy to share.
Yeah, go ahead, Roger.
All right, thank you. Didn't mean to cut anyone off. So what we talked about is kind of beginning with the My Solar System interactive to allow students to kind of really explore solar systems and kind of how they work and how forces are attracted to each other. From there, we discussed, well, let's compare the solar system that you created to, a more structured solar system in the gravity and orbits simulation. And they'll be able to compare the differences between theirs and this one. From there, we would link it back up to Gravity Force Lab Basics to talk about the importance of the mass and how the larger the mass, right, has a greater gravitational force and things of that. And that's kind of how we linked those three.
Thank you. So the simulations that you're specifically talking about, can you see my screen? Give me
Yes.
thumbs up if you can. Okay. So you had mentioned in physics here, I think you mentioned the gravity basics lab right here.
Yes.
This is actually like what we call the Cavendish experiment, where basically we look at what is the force between two objects, and then you can get Newton's third law, right? Equal forces in opposite directions. Nice. Excellent. What was the other one that you mentioned, if any?
Yes, it was, let me see here, I have it written down. Gravity and orbits.
Oh, gravity and orbits. Yes, that was the one that was mentioned by a few folks before. So this is my solar system, and gravity and orbits is this one right here, which really is, yeah, it's a little bit simpler, looks at some slightly different things, and has a setup where it's got the Earth, Moon, Sun system. So nice, thank you. Excellent. Well, for the sake of time, thank you for sharing, Roger. I just wanted to share a couple things. Yeah, I was kind of thinking along the same lines. I would also say it's possible to go even a little more physicsy. There's a number of different PhET simulations focused explicitly on forces and interactions, like linear forces, but still help students build those understanding ideas of the relationship between force and acceleration. And I wanted to throw one other idea out there at people, which again, as a physics person, I often overlooked, and that is sometimes we only look at the science, but the math can be helpful as well. So don't overlook the possibility of integrating math. For example, you know, I know we were looking at forces in different directions. In an orbital sense, it may not be useful, but understanding vectors and vector addition can be helpful. Understanding a variety of different kinds of equations, you know, not necessarily with gravity and orbit specifically, but there's a lot of things in Earth and space science where you get quadratic or linear relationships. You know, even gravity, right? How would a pendulum, how would it swing on the moon versus on the Earth versus on the surface of the sun, let's say. So there's lots of different things there. I wanted to just point out a few additional things. There's other stuff out there. Yes.
Could I say something trivial?
Please.
I find it quite fun, and I think the children will enjoy this because it's almost like a game that they're playing, and it's, you know, so much fun that they will be engaged definitely. And tweaking the learning environment will be a lot easier than with a textbook. So thank you.
Yeah, good. I'm glad to hear that. Yeah, that's for sure. And I like that you said they're almost like a game, because they're not games where you could just hand them to students and say, just learn, right? You can have them like explore for a little while, but then there really does need to be teacher facilitation. So PhET simulations have been designed so that teachers really are helping to guide that experience. Just like you wouldn't throw equipment at a student and say, do science, right? So I'm going to show you some resources for exactly what that can look like. I did want to point out beforehand, though, the simulations that are HTML5 are typically what we look at because that's what works on all computers and tablets and stuff. And that's what shows up under the standard simulations. But if you go to compatibility and then click on Java ChirpJ, sorry, we have a whole bunch of other simulations that have not yet been ported over. So these will work on computers, but they won't work on tablets or on smartphones. And a lot of these are Earth and space science stuff: radioactive dating game, alpha decay, magnets and compass, including the Earth, glaciers. You know, there's some biology stuff in here as well. So please don't overlook some of our legacy stuff, because some of it is extremely relevant to Earth and space science. Okay.
Can I ask you a question
some
here?
folks did ask me about, yes, go ahead. I'm sorry.
Yeah.
I know there's probably a
Yeah.
lot in the chat too.
Yeah,
Go
I was
ahead,
wondering,
please.
when someone talked about gravity and orbits, is there anything, any simulation that covers the conic sections like ellipse or hyperbolas that an orbit would make?
That's a great question. Explicitly, I don't think so. I don't think so. You're talking about like the slices.
Well, yeah, the shape of the orbit could be, typically it's an ellipse. It could be a hyperbola or a parabola, so they're conic sections.
Yeah. So I don't know the answer to that question. I mean, if anything does, it would be the gravity and orbit or the My Solar System. But if it doesn't cover it, then I don't think we have gotten it yet.
Okay, thank you.
Yeah, sorry. Wish I could help more. So I wanted to take you to the web page one more time. So if I'm looking at, let's say, a popular simulation, I'm going to just go to Gravity Force Basics. We have a platform where teachers have been contributing lesson plans and student worksheets. We have almost 4,000 lesson plans. So they're not all vetted, but the way you access those is, so first of all, there's a document called the Teacher Tips, and you'll see it says sign in to view this content. These are intended for teachers. So you have to create an account. It's a free account, and you can opt out of any emails if you don't want emails from PhET. Although our emails are generally helpful. It's things like there's a new simulation or there's a professional development opportunity, but you don't have to sign up for that. So the first thing is the Teacher Tips have basic information about the controls. And I know there was a conversation in one of the groups about, well, what is this? How is this actually modeling and where might it not be perfect? We talk about some of the simplifications we use. There's also information about inclusive features and suggested ways to use it, like questions to ask. And then many of them also have a video primer, which again is intended for teachers, but gives you an overview of what you can do. And then under activities, these are activities that have been contributed by teachers across many years. And you can click on it and you can download them. I've never looked at this one. It looks like it's decent because it's got a star on it. And then it generally comes as like a Google Doc or as a worksheet. And you can use the worksheet, modify it, do whatever you want. You know, it's nice. It's important to give credit to the original author, but if you're just using it in your classroom, you can pretty much do anything you want to it. So there's over, like I said, almost 4,000 resources. Most of them are what I'd call worksheets, where you could have students working in small groups, or you could have students, take it home for a homework assignment. So there's a lot of stuff I didn't cover, but I feel like it's better to answer your questions. So let's go ahead and address questions right now. I don't know if Ashley or Ida, if you have a list for me that have gone through the chat.
Missy, go ahead.
Sure. Ashley, thank you very much for that overview. That's absolutely terrific. Real quick question about the ones that the Java-based ones you have to use the cheerly J or whatever to access.
J, yeah.
Thank you. Is there in the future, do you expect those to be HTML5?
Some we do. It all comes down to who's funding our work. So I am aware that this magnet, all these generator magnets and compasses, these will be updated by the end of this year, probably like in September, maybe in time for the school year. I'm not aware of others that are being actively worked on, because in addition to updating things, we also get funding to create new things. And so, yeah, I know the electromagnetic stuff is coming. I don't know about the rest. I don't believe it's probably within the year.
Okay, terrific. Thank you so much. So let's see, what new simulations do you have in the works?
Let's see. Oh, that's a great question. Honestly, a lot of it's in mathematics, because that's where a lot of the funding is right now. So even if you look at our what we call our prototypes, you'll notice, well, some of them are like what I'd call elementary level kind of mathematics. So center and variability, mean, share, and balance. It's kind of all over the place. I think we're going to have a build. We have one that deals with the hydrogen atom and energy levels. That should be coming out sometime soon. And then we just recently, you can see the ones that are also new. We just recently released Calculus Grapher. If that's relevant for a physics teacher, that's fabulous. I don't know about earth and space science folks, but that just came out 2 days ago, I think.
Wow.
Yeah.
Exciting. When you first did, in the beginning of the presentation, you mentioned something about giving students that time, and I'm all for that with especially my students. I tell them to take 5 or 10 minutes and play with it, try to break it, do everything you can, get out of it, come back in. Do students, can they really break these simulations? Do learners ever feel like they have broken them?
They maybe have found bugs, but that's it. I'm not aware of a student ever having broken anything. I mean, so there's one example. Well, so there's one example I can give you, but it's intentionally built in. By the way, for the person asking about biology, you can see the biology here. But the one that is one that students regularly try to break, and like it's a natural tendency for students, is a circuit construction kit. They all want to see something explode. So it is possible to, let me see if I can do it here. I just need a battery, right? And a wire, I think. Let me see what I can do. So I just made the battery catch on fire. So that's that. And because of that reason, we used to have a dog on this list, because all humans and animals, we can all conduct electricity. And it caused some troubles because people were trying to do mean things to the dog. We had a limiter so that the dog would give a little yelp And then, there was a note, that, because the dog didn't get hurt, but, it felt something. We got rid of the dog because it was too much on the edge. Do you know what I mean? So, yeah.
Wow. Thank you.
Yep.
The simulations are inherently decontextualized. There's no
Yes.
particular place, time, circumstances. What might you say regarding the need to contextualize learning and how the simulations can be applied to contexts that are familiar to students?
That's a really great question, and one we're really struggling with right now. So we have a DEIB advisory board, and that's basically the focus of our conversations. So what we've, kind of at this point, what we've decided is the focus needs to be right now on working with teachers who can help us identify that context, but also build it around the simulation. Building it into the simulation causes a lot of troubles because and when I say troubles, what I mean is building one context often makes it inaccessible to other individuals learning in other contexts. We do work globally. So one thing we're working on right now, I'll just share my screen, just as an example of, I think, the challenge inherent to this, but also the importance is, we're working with countries, like I said, all over. Some of our simulations have characters, particularly in the math simulation. So you may not see this as much, but I've got one example in physics, and that's the energy skate park. We have these characters. Up until a couple of years ago, I think the only character was the one that looks like our director, Kathy Perkins. The character looked like a young white girl with kind of short blonde hair. And we recognize we need to diversify more and such. So one of the things we're working on is localization. We're creating a more diverse character set, but we're also creating character sets that reflect different cultures. So like Africa, also we have a modest version, right, where you've got an adolescent girl wearing a hijab. So that's just one very small example, but we're also hoping to add background scenarios. If I think what the question's getting at, like CK12 does a really nice job of contextualizing. CK12 has beautiful visuals and beautiful, everyday scenarios. But we do find that we struggle with ensuring that we maintain the flexibility that we want for our global audience. And also we do a lot of research on, again, the cognition of learning. And we have found that when we add in additional visual variables, they tend to distract students. So a lot of it depends upon what your objective is. And right now, PhET is probably more comfortable focusing on working with teachers to help them create contexts that surround the simulation rather than building that into the technology, which is frankly also financially just very difficult for us to do. So I want to answer that question with one more thing, because that's one more thing I want you all to know about. Under teaching virtual workshops, we now have a virtual workshop that ties together PhET's recommended pedagogical strategies, including a general intro to PhET simulations, how to use PhET simulations if all you have is a projector, but you still want to engage every student through things like peer instruction, how to write effective worksheets for math and for science, and then finally, how to engage with students as they're working, in small groups and things like that. So these are, freely open. It's basically a combination of videos, readings, and then templates. If anybody's interested in some kind of a facilitation of this where we can give a certificate, just drop me a note. We're happy to do something like that. It's not perfect, but it's our attempt to put everything together after 20 years and to actually look at the pedagogy and not just the technology.
Amazing. Wonderful. Thank you, Rebecca.
Rebecca, I have a quick question. So does this allow testing, and are you able to have some type of foolproof device that will allow you to see who is succeeding with the specific tasks versus the ones that aren't?
That's a great question. And so the short answer is no. Part of that is because we've made a decision to never ask for student accounts. And that's a privacy issue. The US, there's privacy concerns, but places like Europe, basically, if we were to put any kind of like a Google login, we just wouldn't be allowed. in most schools. So we don't do that. There's one small exception. Again, it's not associated with an account, but many of the simulations, I'll just show you one, which is for very young children. Many of the math simulations have gamification. And so while it needs to happen like in the moment, there's automated feedback, and a teacher can see, whether or not a student has achieved a certain level during that session. But if the teacher walks over, right? There is no teacher interface that links to student accounts.
I have students screenshot these
Yes.
games when they finish playing a game, it will feed back and it will give them 4 stars or 3 stars.
Mhm.
I want to know that they've gone through the games and they screenshot their final thing for me. So
That's
I know
perfect.
they've gone through it. And on the
Yeah, that-
Chromebooks, I believe it's Control and the F and the display key will
Yes.
screenshot.
Yeah, that's a fabulous solution. Now, one thing I have not mentioned, because we really haven't publicly announced it, we do have a tool called PhET.io, which is intended to be used mostly by researchers and potentially like for use in like assessment projects and things like that, where it's not connected to the PhET website, and it actually can track all the analytics, can see whether or not a student has answered a question correctly, even allows a teacher to change a setup so that students are focusing in on something. That's a commercial product that we're hoping to launch to help us basically maintain our project for everyone for free, if that makes sense. So
Thank
You
so
mentioned math simulations before, and calculus grapher. Could you, well, first of all, what is the calculus grapher like?
well, let's take a look, because I haven't looked at it yet. So
Oh, okay.
It's very similar to Moving Man, which is now just in Java. But basically it allows you to create shapes, and then this is the derivative of that shape.
Oh,
Right.
yeah.
So here you have a negative, is that what's going on here? We've got a negative slope.
Yeah, that's a negative slope.
And then goes to 0. It looks like, yeah, and then goes to 0, and then we have a positive slope, and then it goes to 0 again. So that's exactly what we're seeing right here. But you can also get areas under the curve. So here we're modifying it from below.
Good.
Yeah.
Well, that's cool. Could you mention any other math simulations that might be of interest?
Specifically for Earth and space science folks, I can't probably answer that immediately, but if you just click over here and choose math, you'll see. I mean, one thing that I think might be relevant when you're looking at distance versus displacement, making measurements, that's a very basic concept, right? But a lot of interesting, I'm sorry, looks like my computer is just a little bit slow, but one thing that I think is highly relevant, well, so things like Plinko probability, when we're looking at data, especially earth science data, right? It's not, and I don't mean this in a bad way, but it's not as clean as laboratory physics, right? Like there's a lot of variability in data that you get out in the field. And so understanding probability, understanding things like least squares regression. How do we know if a line is a good fit to the data? We've got some pretty cool things for that. Things like estimation. This one probably isn't going to work for most people, but estimating is a huge thing in Earth and space science, I think. So, yeah.
Excellent. Thank you. We're going to go ahead and wrap things up here. Rebecca, can I just grab the screen real quick?
Sure.
Thank you. Let me grab it quickly here. Thank you.
And I'll drop my email in the chat for anybody who wants to reach out for any reason.
Thank you. So I did just drop into the chat box the link for our post-webinar survey. Please do complete that. It's really helpful for us, especially as we're preparing for season 9 of the NGSS ESS Working Group webinar series. So please go ahead and fill that out. And it is the only way to get the certificate of participation if you would like to have that. Also, last month we announced to you that there is a new feature for K-12 teachers on the nagt.org website, which is a listing of professional development opportunities for K-12 teachers. So please go ahead and jump on NAGT's website, click on resources, then K-12. and you will get to this page of K-12 professional development opportunities. Has about 38 listings up there right now, so please do jump in and take a look at those for upcoming events across the summer and moving forward. Also, this webinar series and the NGSS ESS working group is brought to you by 3 organizations: NAGT, NESTA, and AGI. NAGT, of course, National Association of Geoscience Teachers, has a number of member benefits. Please jump on the webpage and take a look at those. Missy, NESTA?
Yeah, real quickly, NESTA is National Earth Science Teachers Association, and we're an organization of K-12 educators, teachers that are working with teachers and supporting teachers. Join us.
And American Geosciences Institute. Ed?
I put some things in the chat. Please visit us online to look at the resources that we have for educators, especially the annual Earth Science Week celebration, which is the second full week of October every year. I'd love to have you involved in that as well. Thanks for being here, folks.
And thank you very much to Ashley for running the tech behind the scenes. Thank you so much to Rebecca for the wonderful presentation today. I think we have all found something to do on our next rainy day. We can spend the whole rainy day inside exploring PhET simulations. That's where I'll be. Join me there. On behalf of the NGSS working group, my name is Aida Awad from NAGT, and I thank my other 2 co-conspirators here, Ed and Missy, for a great year this year. Thanks very much. Have a great afternoon, everybody.